In 1957, programming meant giving computers painfully detailed instructions. In 2026, a software engineer can type, find the bug, fix it, run the test, and show me what changed. And an AI agent can actually start doing it. Those sounds like two completely different jobs, but they are not. They are the same profession, separated by almost 70 years of abstraction. And if you follow this timeline, there is a pattern that might tell us what software engineers become next. In the early days, programmers worked incredibly close to machine. Then come Fortran in 1957. Instead of manually describing every tiny machine operation, programmers could write a high-level language and let a compiler translate it. Here's how dramatic that was. IBM gives an example where something requiring as many as 1,000 machines instructions could be expressed in just 47 Fortran statements. That was the first huge shift. Programmers stopped telling computers every single step, and this pattern is going to repeat. Software kept getting bigger. By 1968, NATO was holding a conference specially on software engineering. Because making code run wasn't enough anymore, engineers now had to think about design, reliability, maintenance, architecture, and entire teams building complex systems. Then programming languages kept moving us farther from the hardware. 1970s, C. 1991, Python. 1995, Java. Each generation asked developers to think a little less about the machine underneath and a little more about the problem they are solving. But then something happened that changed programming without inventing another language: the internet. GitHub launched, and that same year Stack Overflow went public. Suddenly, a huge part of being a programmer became search, reuse, install, integrate. Need authentication? There is a library. Need a database driver? There is a package. Getting a completely incomprehensible error at 2 a.m., someone on Stack Overflow had probably already suffered for you. Software engineers weren't just writing code anymore, they were assembling ecosystems. And then, even the computer running that code started disappearing. In 2006, Amazon launched EC2. Instead of buying a physical server, developers could request computing power through software. Then, 2013, Docker. 2014, Kubernetes. Deployment itself moved behind more abstraction. The question gradually changed from which machine will run my code to how should my system scale. And now look at what's happened so far. Machine instructions abstracted, libraries reused, servers virtualized, infrastructure automated. There was really only one giant thing left: the code itself. In 2021, GitHub introduced Copilot. AI wasn't sitting in another website, it was sitting inside your editor, suggesting lines, functions, tests while you coded. Then in 2022, ChatGPT made something even stranger feel normal. Instead of Googling Python sort dictionary by value, you could just say, write this for me. But autocomplete was only the beginning. Because in 2025, tools like Cloud Code and Codex started behaving differently. You weren't just asking, give me some code. Now you could say, fix this bug, and the agent could read your repository, find the relevant files, edit them, run the test, see what failed, and keep working. Think about that shift. We went from engineer writes code to AI helps engineer write code to engineer give AI a task, and then 2026 pushed it even further. Today, developers can have multiple coding agents working in parallel, one solving a backend problem, another working on test, another investigating a bug, while the engineer moves between them, reviews their work, corrects them, and make the important decisions. And that creates a slightly uncomfortable questions. If AI writes more and more of the code, what exactly is the software engineer doing? History actually gives us a clue. When Fortran arrived, programmers didn't disappear because they stopped writing machine code. When cloud computing arrived, engineers didn't disappear because they stopped installing physical servers. Every abstraction removed work from one layer and moved engineers to a higher one. AI looks like the next version of that. So the valuable question is shifting from how do I write this function towards what should we build, how should the system work, what are the trade-offs, what can fail, and maybe most importantly, is the AI actually correct? Look at the evolution. 1957, tell the machine how. 1995, tell the language what. 2021, let AI help write it. 2026, tell agents the goal. Software engineers aren't disappearing, they're moving up the stack. And the engineers who still understand what's underneath that stack may become more valuable than ever. If you like this video, do me a favor, please hit that subscribe button. See you in the next one. Peace.